Hi, this is my problem situation. First, I have to say that we are studying damped motion. So to do so, first we did an experiment with a spring. We put a known mass and then we measure the elongation of the springs, and with Hooke's law we calculated the constant of the spring. After that, since we wanted to know damped motion, we see the three different types of damped motion. Then we studied another known mass. We put it on the spring, knowing already the constant in oil, and we got this graphic from Tucker of the motion in the y-axis. After that, we graphicated the top results, the natural logarithm of those values versus time to obtain b, and then we use this equation to calculate the critical mass of this spring. Knowing the critical mass, you can see that it's really low. We couldn't actually measure it with our balance because it was lower than the lowest value we could measure. So we used the lowest value we could measure, and we used that to do our experiment. We were expecting to see a critically damped motion, but you can still see some isolations, and that is because, well, we didn't have the correct mass that we calculated. And then after that, we took it to a real life situation that are shock absorbers, of course. I took, for example, the Bocho. That's my favorite car, and its mass is 716 kilograms. First, I calculated the weight in each wheel because it has 4 different shock absorbers. After that, we use Hooke's law to calculate the constant of those springs, and we chose an elongation of 6 centimeters, and that's why we got that result. And then after that, I calculated b using this equation, and well, we got this value. You can see that the results of this real life situation are much more higher than the other one. That's because we have a much larger and heavier situation going on here, so it's normal. And that's it.